In this video, you are going to learn about density. What is density? Density, it is the mass occupied by a unit volume. So density of a substance, usually we use a letter rho, it pronounced rho, that is equal to mass per unit volume. We try to use this letter to replace density D because D sometimes is used for distance. Okay, let's look at an example. Over here, a block of metal occupies a volume of 15 ml and weighs 40.5 grams. What is the density? Okay, before we do anything, let's look at what should be the unit for density. As for mass, the SI unit for mass is kilogram, and the SI unit for volume is meter cube or cubic meter. So this one is the SI unit for density. However, we do not use this one very often in chemistry because when we measure the mass or the weight, we usually use a balance or a scale, and this will be the unit in grams. As for the volume, you can either use liter in this case in order to match with this SI unit. We prefer to use cm cube or cubic centimeter. 1 cubic centimeter, it is equal to 1 cm by 1 cm by 1 cm. Okay. It is the same as 1 ml. So 1 cubic centimeter, it is the same as 1 ml. When we talk about the volume of a liquid, very often we use ml, and when we talk about the volume of a solid, very often we use cm cube. But these two can be interchangeable. All right, let's get back to our problem. Okay, so over here, we are looking for the density from the formula from before, rho, that is equal to mass divided by volume. In this case, the mass, it is 40.5 gram, and the volume, it is 15.0 ml. So let's try to do the calculation. 40.5 divided by 15.0, what I get is 2.70, and the unit will be grams per ml, or we can say gram per cubic centimeter. Okay, look at the title over here. It says identify unknown materials by using density. So how can we identify this material? It just say a block of metal. It did not say what metal it is. But now we know the density. Okay, so let's look at this density and compare with some known density of the metals. And let's see, 2.70. So what I'm looking here is density over here will be gram per cubic centimeter. And over here, the first one, 2.7. And there is nothing else that is close to it. And therefore, we will say that block of metal, it is aluminum or aluminum alloy. Over here, you see that it's called specific gravity. What is it? It is assuming that the density of water at about 14.5 degrees Celsius or around room temperature, and is at 1 atmosphere, then the density will be exactly 1.00 gram per ml. Specific gravity means by using the gravity of the measurement and just divide by this number. In other words, it is a comparison of the density of what we are looking for to the density of water. If it is less than 1.00, that means it is lesser than the density of water. And as a general rule, very general rule, that means if you have something that is not soluble in water or in any liquid, and when you put into that liquid, if it sinks, that means the density of that object is higher than the density of that liquid. If it floats, that means the density of the floating object will be lower than the density of that liquid. By saying that, let's look at an example. I have water over here. Based on our experience from daily life, when we put oil, the oil will float on top of the water here. The question will be, what about the density of oil? Will that be higher than that of water, or will the density of oil lower than that of water? Well, if it floats, based on what we said over here, if it floats, that means the density, it will be less than that of water. That means the density of oil is less than the density of water. All right, so here, by comparing the density, we know that the unknown material, it is aluminum alloy. Okay, so what happens if the volume is not given as for regular shape object? For example, if we can tell that if the object is very regular, for example, if it's either cubical or with other shape, okay, so rho, that is equal to mass divided by volume. Mass, we can always measure it by using a scale, or we call it a balance. Most likely in a nowadays lab, people use a digital scale. Okay, how about volume? Volume, if it's a regular shape, that means there is a formula to calculate for the volume. Yes, we can calculate for the volume. Okay, if it is a shape like this, then the volume will be equal to A times B times C. If it's a cylinder like this with radius R and the height H, then the volume will be equal to pi R squared, so that is the area of the base, and multiplied by the height. If the shape is a cone shape, where the radius is R and the height is H, in this case, the volume of the cone will be equal to 1/3 pi R squared times H. If we have a sphere, the volume of a sphere is equal to 1/3 times pi R cubed. Okay, so these are the regular shape that when we measure the dimension, we can actually calculate for the volume. So what happened with the irregular shape? There are two types of irregular shape. First of all, if it's a liquid, then there's no certain shape. So how do we get the density of a liquid? Remember, density rho, that is equal to mass times mass divided by volume. Okay, so let's say we have a scale over here. This digital scale can give the reading of whatever mass that we are putting on. So in order to measure the mass and the volume, we can put the liquid into a graduated cylinder. So it will typically look like this, where you pour the liquid in, you can see how much volume that it occupied. Okay, so how do we do that? We can first put the graduated cylinder on top of the scale or the balance, and we measure the mass. Let's call this is mass initial. And then we pour the liquid in it. We can see the volume, so we find out the volume, and also we can see the final mass over here. So mass final minus mass initial, that will be the mass of the liquid that was poured into this graduated cylinder. At the same time, we can read the volume over here. When we read make sure, for example, if it's aqueous solution, we need to look at this meniscus. If it's mercury or some other type of special liquid, then we are going to read it over here. Okay, so as for the liquid, we can measure the mass and the volume, and we can calculate for the density. There are other types of irregular shaped object. For example, if it's a solid object, let's say it will look like this, then there is no formula that we can calculate for this, for the volume of the object. However, we can measure the mass. So what we can do is, first, we measure the mass of the object by using a balance. Secondly, we are going to measure the volume. How do we measure the volume? We should have a liquid, and we need to use a graduated cylinder. So what we can do is, we are going to fill the graduated cylinder with a liquid. There are two requirements for this method. The first requirement it is, this object, it is not soluble in this liquid. Otherwise, when you put it in, it will be dissolved, you have nothing left. Okay. The second requirement is, it must be sinking. It must be sink to the bottom of the liquid. Otherwise, when it flows, then you cannot measure the liquid, the volume of the object that easily. Okay, so the first thing is measure the mass of the object. Later, put the object in here. Before that, let's read this one. So this one is V initial. But after you put the object in, what happens is, this liquid level is going to raise to a new volume reading, V final. So what is the volume of the object? The volume of this object will be equal to, volume of the object will be equal to V final minus V initial. Okay, so that is this volume over here. Now we know the mass, we know the volume. Yes, we can calculate for the density. In case that it flows, okay, yes, there are ways to do it. The mass, we are going to use the balance to measure the mass, however, with the volume. So for example, if I want to measure something that floats, let's say I want to measure the density of a foam, okay? However, the foam is going to float, so how can I measure the volume and its irregular shape? Well, we can use a known volume, let's say metal or anything that is very dense that it will sink. So we put the foam inside here, and we also put this heavy metal to be on top of it. So now everything is submerged in water. So we can say is V final minus V initial, that will be equal to the volume of this heavy metal or the metal on top, plus the volume of the object. That's how we can look at the difference in the water level and the known volume of this heavy metal that is on top. Yes, we can calculate for the volume of this object. And then we can calculate for the density. Sometimes when the object is very small, how do we measure the density? Okay, for example, if I get a piece of sand from the beach or from somewhere, but I'm not sure if that is sand or not, or let's say the density is around 1.2. How do we measure its density? We don't know what the density is, but we know that it is anywhere between 1.0 to 1.2. How do we measure the density? Usually we can manipulate with the density of the liquid. For example, we just put it in water now and it will sink. We slowly add salt into water to increase the density of this water until this object starts to flow. Once it starts to flow, that means the density of the object is equal to the density of the liquid. And then we can try to measure the density of the liquid so that we know what the density of this object